Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 13, Mastering Factoring. Mastering. Opening exercise, factor each of the following expressions. What similarities do you notice between the examples in the left column and those on the right? So here we go. It's an exercise. Pause the video, see if you can do these, and then come back and check them. All right, so A, this is called difference of squares. So that means that we have this, and you take the square root of the first term, and that goes there and there. And then it's plus minus the square root of the second term, and we are done. Okay, difference of squares, very simple. And then if I come over here, well, 9's a perfect square, x squared is a perfect square, and 1 is a perfect square. So guess what? We have a difference of squares. Square root of the first term would be 3x. Square root of the first term goes here, plus or minus square root of the second term. Boom, done. Okay. C, factors of 15 are 1 and 15, 3 and 5. Factors of C that add up to B, 5 plus 3 is 8. So it's going to be x plus 3, x plus 5. Okay, we're done. This one has an A that's not 1. And sometimes they're really easy to do, sometimes they're not. So I always do them this way. 4x squared plus 16x plus 15. And keep in mind, we should always find or look for the greatest common factor first. So I know 4 will go into 16 4 times, but 4 won't go into 15. So there are no common factors. So then what I do is, and the only reason I do this is because we don't always know if it's going to work as easily as this will come out, but I'm just showing you this just in case. X squared plus 16x, and we multiply A times C, and 15 times 4 is 60. And then this will split up into x, and it's all positive, so it's all positive. And then I look for factors of 60. So that's 1 times 60, 2 times 30, 3 times 20, 4 times 15, and 5 times 12, 6 times 10. And as I get closer, as these numbers get closer, 7 won't go, 8 won't go, we're done, and they repeat. So I'm looking for factors of C, which is 60, that add up to 16. Well, it's the 6 and the 10. So this is x plus 6, x plus 10, but don't forget we divided by, or multiplied by 4, so we have to divide by 4, and this simplifies to x plus 3 halves times x plus 5 halves. We can't have a fraction over here, so we move the denominator over and put it in front of the x. And so finally, this is going to equal, I'll put it over here, 2x plus 3 times 2x plus 5. Okay? So there's that one. Now notice what happened there. It said to compare the left column with the right. We'll get back to that after I do E. Okay, this is a difference of squares. X squared is a perfect square. Y squared is a perfect square. So you take the square root of the first term plus or minus the square root of the second term, and we're done. This is a perfect square. This is a perfect square. What times itself gives us x to the 4th? Well, it's x squared. X squared times x squared is x to the 4th because we add exponents when multiplying. And it's plus or minus, and y squared times y squared is y to the 4th. So there we have it. We are done. It's that easy. Now it says, what do you notice about the examples in the left column and the example in the right? Well, this was x squared minus 1, and we got x plus 1 times x minus 1, and then this had a 9 in front, so it's a multiple of 3, but the 1 didn't change because 1 squared. 3x minus 1 and 3x plus 1 cancel, and 1 times 1 is still negative 1. In this one, the number, the constant, was still 3 and 5, but the x became 2x to give us this 4x squared. And the same with down here, x plus y, x minus y, and then factored into the force is x squared and y squared. Okay, example 1. It says to write 9 minus 16x to the 4th as the product of two factors. So 9, the square root of 9 is 3, so 3 squared is 9. And then I'm going to write minus, and the square root of 16 is 4, and the square root of x to the 4th is x squared. So this would be 4x squared squared. So now we have a difference of perfect squares. So we can simply do this. The square root of the first term plus or minus the square root of the second term. Okay, and that's it. Okay, page 2, example 2 says to factor this 4x squared y to the 4th minus 25x to the 4th z to the 6th. And since I see that 4 is a perfect square and 25 is a perfect square and 2, 4, 4, and 6 are all even, the square root of variables to a certain degree, if the degree is even, the square root is half of that. So I see that these are both perfect squares. So this is going to be equal to the square root of 2, the square root of x squared, the square root of y to the 4th, all squared. So if I distribute that, I get this, minus the square root of 25, the square root of x to the 4th, the square root of z to the 6th, all squared. So if I distribute this, I get this. Okay? So once I do that, this is a difference of squares. So this is going to be the square root of this is what's in the parentheses. So it'd be 2xy squared plus 5x squared z cubed times 2xy squared minus 5x squared z to the 3rd. Okay, so hopefully you followed that. It's just the square root of the first term plus or minus the square root of the second term because this is a difference of perfect squares. Then once I do that, I can factor out an x from each of these. So this is going to equal, as you can see, I have an x here and I have an x here, I have an x here and I have an x here. So if I factor out an x, this will leave me with 2y squared plus 5. I took one x away, but there's still one there. And then the z cubed stayed the same. And again, I factor out an x here, and that is going to be 2y squared minus 5x squared. Took one x away, there's still an x, z cubed. So I factored out those two x's. And I should show this like this, I guess, brackets around these two different terms, like so. Okay, so now I have this times this, and there's an x in each. So now I can pull those x's out. And since it's x times x, it becomes x squared, and then 2y squared plus 5xz cubed times 2y squared minus 5xz cubed. And we are done. That is example 2 factored. All right, so now exercise 1. These are exercises. Pause the video, see if you can do them. Come back and see how you did. Okay, so here we go. Here's number 1, example 1, exercise 1. Factor the following expressions. So when I look at this, there's no greatest common factor, but this is a perfect square. And Okay, so what are we going to do here? We're going to write this as 2x quantity squared plus 2x squared. No, that would give me an x squared. What can I factor out of 4x? It can be a 2. So I could say this is 2 times 2x. So what I'm doing right here is I want my parentheses to match. So if I took the square root of the first term and I got 2x squared, then I want 2x in the parentheses. And what do I have to multiply it by to get 4x? And that is the 2. And then the minus 63 just follows along. Okay. So then what I do is take this 2x and write it like this. And then I want plus or minus, and I want the middle term to be positive, and I want the product to be 63, so I do 9 times 7. Okay, this one takes a little bit of work. I'm going to show it to you the way I normally do it, and that would be 4x squared plus 4x minus 63. And I take the 4, which is A, and multiply it by C. And that will give me x squared plus 4x. And 63 times 4 is 100. 4 times 3 is 12. Carry the 1. 6 times 4 is 21 plus 10, or 1 is 25. So that would be minus 252. So that will give me x, and that would give me an x here. And then I take factors of 252, which are 2 times 126, 3 times 8, 4. And this is kind of a large number, so I'll use my calculator. You decide which way you want to do this. 252 divided by 4. Whoops, what's going on here? 252 divided by 4 is 63. 4 times 63. So what am I looking for? I'm looking for a difference of 4. Well, these are huge. This is 59, so I got to keep going. 252 will not be divisible by 5 because it doesn't end in 5 or 0. I will try 6, and that's 6 times 42. Obviously, still way off. We're still 36 off. We have 36. So if we subtract these, we want 4. 252 divided by 7 is 36. 36 minus 7 is 29. So we're getting closer. We want to get down to 4. 252 divided by 8. 252, the divide button didn't work. 8. No. 252 divided by 9. 28. So this is 9 times 28. That will still give me a 19 difference. So we're still going. 252 divided by 10. No. 252 divide 11. No. 252 divided by 12 is 21. So it's 12 times 21. That's a difference of 9. 252 divided by 13. 14. There it is. 14 times 18 is a difference of 4. So it'll be plus 18 minus 14. And we divide it by the 4 that we multiplied by. And we get x plus 9 halves times x minus 7 halves. Bring the 2 over here. And we get 2x plus 9 times 2x minus 7. So as you can see, we got the same numbers here. You decide which way you want to do it. So let's recap this one. We took the square root of the first term and found what was in parentheses and said the middle term has to have the same parentheses. So I factor something out to get that, and it's 2 times that 2x, and then the minus 63 goes there. Since this 2x repeats, it's our first term, and the factors of C that add up to B. So maybe this way is easier than this way. In that case, it obviously was. All right, so in this one here, we're going to do the same. All right, so we have a 12, we have a 24, we have a 15. Those have a greatest common factor of 3. So the first thing I'm going to do is factor out a 3, leaving 4y squared minus 8y minus 5. So then this 3 comes down, and we're going to do like what we did up here. And now this 4y squared will be 2y quantities squared minus, leave a space, put the 2y here, and I had to multiply that by 4 to get 8, and then minus 5 out here. And so that 3 comes down again, and this is going to now break up to 2y and 2y. And factors of 5 that add up to 4 are 5 and 1. And the middle term is negative, so it's minus 5 plus 1. Okay, so in doing this though, we have to decide, actually that'll work. It doesn't matter what order this is. If I put plus 1 here and minus 5 over here, it would come out the same. So order doesn't matter there. So that is the answer. So I suppose this is much easier than this method right here. Okay, but if you want to see that other method again, I'm going to do it. So again, we're going to start with the factored form. We have to get the GCF out first. And then what I'm going to do is I'm going to take this 4 and multiply it by minus 5, and I'm going to get y squared minus 8y minus 20. And that's going to give us, this one's easier because the number wasn't large. So 20, factors of 20 are 1 and 20, 2 and 10, 4 and 5. We want that to add up to 8, so it's the 2 and the 10. So it's minus 10y plus 2, but don't forget we divided by 4. So we put that back, we reduce, that's 5 halves. That's 1/2, and then the denominator becomes your leading coefficient. So it's going to be 3, 2y minus 5, 2y plus 1. So this is just, almost as easy as doing this over here when you don't get a large C. Okay. Okay, page 3, exercise 2, 3, and 4. Pause the video, see if you can do these, come back and see how you did. So in this case, these are not squares, they're cubes. A cubed, 3 cubed, x cubed, 4 cubed, 2x cubed, factor out a 2, that would be 64, that'd be 8 again. No, 4. 4 times 4 is 16, times 4 is 64. Okay, so anyhow, they're cubes, all 3 of them. But we can't just simply do this. We cannot say a plus 3, a minus 3, because that would only give us a squared. So what do? Well, this cube root of the first term is a, and the cubed root of the second term is 3. So a plus 3 is a factor. But what is the other? If we don't remember the formula from a prior lesson, then we can do this. We can say a plus 3 and do some long division here. Okay, and then if I take a cubed plus 0a squared plus 0a plus 27, okay, and see what I get the other factor is, then it'd be a squared times a is a cubed. A squared times 3 is 3a squared. And then I subtract that and I get nothing here. 0 minus 3a squared is a negative 3a squared. Bring down my plus 0a, and I need a negative 3a here to get negative 3a squared, and then minus 3a times 3 is 9a. And then when I subtract those, I get nothing here. 0 minus a negative is plus 9a. Be careful with your signs. And bring down the plus 27. And 9a divided by a is 9. So I get 9a. And 9 times 3 is 27. And when I subtract, I get a remainder of 0. So the other factor is a squared minus 3a plus 9. So where did this come from? Well, if we have a cube like this, the sum of cubes is what this is called, then it's the positive cube root plus the cube root times a squared minus xa, if you will, plus x squared. Okay. With the minus, it's the same as this, except this becomes minus and this becomes plus. So if you remember those from prior lessons, rather than doing this over here, I'm just going to say, well, okay, the square root of the first term is x minus the square root of 60, or cube root, I mean. Cube root of the first term is x. Cube root of 64 is 4. So it's x minus 4. And then I'm going to take my a, which is x in this case, and that's going to be x squared. And then it's not going to be minus here. See how the signs are going to change here. This was plus, now it's minus. This is minus, now it's going to be plus. And then I'm going to get the value that is here, which is 4. It matches this, and it's going to be x. And then it's going to be plus 16. Which is this squared. So I get x squared plus 4x plus 16 times x minus 4. Okay, so just be careful with that. So let's recap this. Cube root of the first term minus cube root of the second term times the first term squared, because x times x squared will give us x cubed. X times 4x will give us 4x squared. And then when we multiply these, we're going to get a minus, and things are going to cancel. Okay, we're going to get minus 4x squared here. We're going to get minus 16x, but we got a plus 16x from this. So if I distributed that, it will become this. Okay, so minus first term squared plus first times second term plus last term being this one squared. Okay, number 4. This one has a factor, so I can factor out a 2, leaving x cubed plus 64. So the 2 just goes along for the ride from now on, and you take the cube root of the first term plus the cube root of the last term times the square root of the first term minus first times last term, and then the last term squared. And we are done. Okay. Okay, page 4 brings us to the end of lesson 13. Review the lesson summary, difference of squares, sum of cubes, difference of cubes. There they are. We just did those on the last page. So review that lesson summary and go to your problem set.